31, 3x plus square root of 7 squared. Okay, can we just square each term individually? No, you have to do 3x plus square root of 7 times 3x plus square root of 7. All of it times all of it. So, it's a FOIL problem, yes. What's the first going to be? What's 3x times 3x? 9x squared. Throwing me off, you sitting right there. Okay, and then what's the outside? 3x times square root of 7.
3x squared 7.
Yeah, can't really do anything with that. The inside is the same thing, right? 3x squared is 7. If you want to, you can kind of skip those two because you could just say it's 6x squared is 7. And then the last, what's square root of 7 times square root of 7? 7. So, the middle are like terms, they add together. So we got 9x squared plus 6x squared is 7 plus 7. Alright, 33, 4 over 1 plus square root of 5. Okay, so calculator should be able to do this, but how do we do this by hand? Like if there was letters involved, for example, what would we have to do?
Multiply by square root of 5.
No? Okay, if there's two terms, so normally if it was 4 over square root of 5, you multiply top and bottom by square root of 5. So you have to multiply by, if there's two terms, the conjugate. So you have to multiply by 1 minus square root of 5. On top and bottom. And then the top would be distributive property. 4 times 1 is 4. 4 times square root of 5 is 4 square root of 5. And the bottom is a FOIL, but what makes this easier?
Only do the outside.
First and, no, those are the ones you skip. The first and the last. If you're not sure, just do the whole FOIL. But the outside, inside cancel out. So the first and the last, 1 times 1, and square root of 5 times negative square root of 5.
So negative 4.
Okay. Can I do anything else? Yeah. If they're both divisible by 4 or negative 4, you can do that. Both terms. So 4 over negative 4 is negative 1 plus square root of 5, yes. Negative 4 divided by negative 4 is positive 1, square root of 5, so plus square root of 5. Four plus 3i, 1 minus 2i. Let me check the evens. Are there any weirdies?
34.
Just multiply top and bottom by I. On 30, actually, let's talk about, I want to talk about 20, I guess. Has anybody tried 20 yet?
Yeah.
Let's see if you agree with what. So, it's kind of a pain. The book didn't say you have to put everything in radical form, but they did put everything in radical form, including like number 20. So, what does the 1/3 power mean? Well, not cubed. Cubed root. So, did I already? It's a b cubed. So the 1/3 power means to the first power and the third root. So in other words, it's the third root of all that stuff. And then what they did was, well, not much. There's only one thing you can simplify. Yeah, remember how yesterday we did like 2 divided by 3? Now, 2 is not big enough to divide by 3, so just leave that alone. And you can't do anything with the 3, but what's 3 divided by 3? 1. With the remainder of 0, right? So that means 1b comes out and 0 b's are left behind. So they put that. Does that make sense? I think the 1/3 kind of makes it confusing. It's not a radical. Okay, back to 35. 4 plus 3i, 1 minus 2i. Okay, I remember stands for like the square root of -1. You can't leave it on the bottom, just like you can't leave a square root on the bottom. How do I get rid of it on this one? No. Just like the last one, if it's 2 terms, you have to multiply by the conjugate. If you just multiply by I, you get 1i plus 2, so you'd still have an I on the bottom. So the trick is multiply by the conjugate, 1 plus 2i. So the top is a FOIL problem. 1 plus 2i times 4 plus 3i. The bottom is an easy FOIL problem. So the top, first, 4 times 1. Outside, 4 times 2i. Inside, 3i times 1. And last, 3i times 2i. What's that?
5i squared.
No, 3i times 2i.
No, 6i.
6i squared. And what's 6i squared turn into? Yeah. -6, so -6. Okay, the bottom, since they're conjugates, just do first and last. First, 1 times 1. Last, -2i times 2i. -4i squared, which turns into +4. Okay, so on the top, on the top I see 4 minus 6 and plus 8i plus 3i. On the bottom I see 5. Well, since it's imaginary, they probably split it up. Just put both of these over 5. Remember how I had you guys split it up back when we did the quadratic formula chapter, whatever chapter that was. And also the I can be written out here. 11/5 times I, whatever. 37, doesn't matter. Square root of x plus 5 equals 4.
That's 38.
Oops.
What are you doing 30?
How would you do 30? How would you do this one though? -5 and then what?
5 squared.
Okay, but what do we need to remember on these?
Plus or minus.
No, that's when you square root both sides. Okay, sometimes when you square both sides, you get extra answers. Like if you try plugging one back, like sometimes one side turns from negative to positive, and another one doesn't. That's when it happens. If you plug it back in, it doesn't work. So it's actually 30. Make sure you're showing your work on these. I was pretty harsh on page 316. If I didn't see the work that correlated to the answer, I put -2 down. So that goes for you too, Kira. You haven't done that one yet, but make sure you show your work on those. Which you normally do, but just in case. Whoops, what am I doing? Okay, now This one might be the worst. Yeah, it is. Okay. You guys remember how we did this one? It's kind of like 14 and 16 off a page.
Subtract.
You gotta square both sides, but first off, if I just square both sides like they are right now, I'm not gonna get rid of any square roots. Oh, well, I lied. Both of these square roots are the same, actually.
Yeah.
So that's gonna make this a lot easier. Yeah, if they're the same square root, if I subtract this one off of this side, it's gonna be able to combine with this. Which one was the hard one? 42 is kind of hard. 43. 43 is the hardest one. Okay. Anyways, so I probably should go to 44.
No.
Yeah, let's go to 44. Okay, so if I subtract one of these, because I want to do at least one hard one. 4 of these plus minus 1 of these is 3 of these. Okay, it's kind of like 4x minus x is 3x, except for it's a weird square root thing. Okay, so it's kind of like, how do I solve 3x minus 1 equals 8? Plus 1 divided by 3. You want to get the square root by itself. Plus 1. We're going to do it one step at a time, quickly. Okay. Square. So we get x minus 2 equals 9. You square, the square root goes away. So x is 11. Does that work in this answer? Should. 11 minus 2 is 9. Square root of 9 is 3. Times 4 is 12. Minus 1 is 11. 11 minus 2 is 9. Square root of 9 is 3. Plus 8 is 11. Yeah, it does work.
So on 38, since it doesn't work, what do we put as answers?
Yeah. Sometimes there was 2 answers and only one of them worked. You guys remember that trick also? Y squared is 7 plus 8y equals 6. Alright, we did do one of these. I'm almost positive everybody forgot how I did it. I'm pretty sure it was just an odd, maybe not an even. No, not exactly. Kind of, but kind of not.
Wait, do you get one on the other side?
No. Okay, what you have to do, so yeah, moving it to the other side is not going to solve it. You can take a y out of the left side. Like factor it out. It's kind of like the opposite of distributive property. Instead of multiplying it out, you take it out. And if this parentheses is multiplied to y, how do I get rid of the parentheses? Divide by square root of 7 plus 8. Alright, so that goes away. Is that it, or is there something else?
You can't have the.
Can't leave that in the denominator, just where a nice calculator comes in. So you have to multiply by the conjugate, kind of like the problem we did like a few problems ago. So you got to multiply by square root of 7, minus 8. Distribute. Foil, but not the whole thing. Square root of 7 times square root of 7. 8
Minus 64.
times minus 8. 7 minus 64, I believe that's negative 57. So 6 squared is 7 minus 48. Negative.
Doesn't that sound?
57, yeah, 3 does go into that, doesn't it? Darn it. So if we divide by, I'm going to divide by negative 3. You don't have to, but on all these. That's probably what the book put. Maybe 16 minus 2 squared is 7. Is that what they put? Wait,
39,
they didn't reduce. They stopped right here. Did the book make a mistake?
No, you're just smarter than
No.
Yes, you're Jordan.
Yes, he is.
Yeah, the book made a mistake, I'm pretty sure.
Well, it's supposed to.
They stopped right here, basically. They just put the negative right there. So yeah, all those are divisible by 3.
Jordan is superior to the book.
How does that keep doing 40?
We're about to do one like it on 41. 81 to the x minus 1. Oh gosh, this one is a particularly nasty one. 40 is the easier version of this. Do you guys remember these problems? Maybe not. You change them to the same base. Usually they were a lot easier, like 4 to the 2x equals 8. And you change them to like the same base. 4 and 8 can both be changed into powers of 2. You guys remember doing something like that? Anyways, these both have this, 81 and 27 both have the same base. Does anybody think they might know what it is?
Is it 9?
Well, 9 times 9 is not 27, so not 9. 3. Yeah. 3 to the what equals 81? 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th is 81, so I'm going to replace that. 27 is 3 to the 3rd, so what's 1 over 27? I'm always disappointed by our lack of knowledge of negative exponents. So it's just negative 3rd if it's in the denominator. If it's flipped upside down, it's a negative exponent. Okay, and then this is like, yeah, you multiply these together, power to a power. So it's 3 to the 4x minus 4 equals 3 to the negative 3rd. Then what? Okay, if the bases are equal, to make these equal, the exponents have to be equal, right? That has to equal that. So 4x minus 4, negative 3. So you got to make the bases the same. That's the trick. Same thing on 40. And then do your algebra. Some people put 4 in a problem like this. What's the answer supposed to be? 1/4. Maybe if we have a day that I need to fill, we'll do a negative exponents worksheet. Just for fun, just for giggles. Yeah. Boom. 3x plus 26. 40, or you can rewrite them as powers of 5, right? 3x plus 26. Okay. Now, this was the tricky one. What do you guys think we should do first? Square both sides. That will get, put parentheses, yeah. That'll get rid of the square root on the right, so that solves half our problem. It will not get rid of the square root on the left, because the left is a giant FOIL problem. Like this times itself. This was the hardest problem off of page 316. Huh? Well, you did the whole thing? So we gotta FOIL this. What's first? 3x minus 6, 3x minus 6. They're both square roots. What do you get when you multiply square root times itself? The thing that was inside, yeah, 3x minus 6. When you square a square root, the square roots go away. Okay, outside, what's 2 times that? It's just 2 of those. Like 2 of those. And then inside is the same thing. 2 times that. So we have 2 of those plus 2 of those, and that makes 4 of those. Outside, this is outside, inside. I went and had to put them together. And then the last is 2 times 2. Okay, that was the hardest part, although we got a lot of work left. Do you guys remember what we did next on these? Any ideas? Okay, minus 3x, right? Because what's going to happen to that? Gone. The negative 6 plus 4, I guess I'm going to put those together. Negative 6 plus 4 is negative 2. Okay, now it's looking like an easier problem, right? We're getting it much simpler, kind of like a problem we did like 5 minutes ago. Okay, so how do I get rid of the square root now? Square. Okay, kind of back to the basics here. Comes out weird. You guys said you didn't get it. Is it because there's a fraction you put in a solution, or did you actually check it?
The ones we did before, not on this exact one, on the review.
Okay, anyways, 55 thirds probably works. If I plug 55 thirds times 3 is 55, minus 6 is 49, square root of 49 is 7, plus 2 is 9. This wasn't here originally. 55 thirds times 3 is 55, plus 26 is 81, square root of 81 is 9. Works. Okay, we'll stop there.
How long will fit with the other class